right. Well, welcome to this Data Lab workshop, Data Cleaning with Python. If you registered for the workshop, you received an email from me earlier today that had a link to a Google Drive folder. All the content for this workshop is in that folder. That you should be able to access without signing into Google. Taking a look at that folder here, we have a couple of items. We have the PowerPoint slides that I'm going to be going through today. We have the Colab notebook that we're going to be using to run the Python code. And then we also have this folder of workshop data. If you're going to be following along with me, then I would recommend going ahead, clicking on this More Actions button and downloading this whole workshop data folder. It's going to download as a zip file. I'm going to do that right here on my machine because I'm going to be running the code also, obviously. Check up in your top corner for your downloads. If you're not seeing anything happen, I'm going to open up that folder. I can see that the zip file downloaded to my downloads folder here. I'm going to right click and I am going to say, I'm going to use 7-zip here. You could either use 7-zip or you can use extract all to download, or excuse me, to unzip the downloaded files. Within this folder, we have several CSVs that we're going to be using, and we'll kind of take a look at each one of those as we get into it. Okay. Flipping over to our presentation, we'll just get into it. So today, as mentioned, we are going to be talking about data cleaning with Python. A lot of us might not be using Python in our daily work, but maybe we're coming across some data sets and we feel like maybe a little bit more automated data cleaning is warranted. And so the whole purpose of this workshop is not necessarily to give you like a from the start version of how to use Python. I'm going to assume that maybe you're semi-comfortable with things like variables and maybe running code, but this is going to dive a little bit further into the syntax, giving you some really common data cleaning steps that I find I do all the time, and so I just wanted to pass these along to you all. Okay. So we're going to kind of talk about some basic info first. When should you even use Python? Well, so I would suggest maybe using Python all the time, but it's not necessary really unless you get to the point where you're needing to do things that are automated, you are maybe doing them more than once. And also good for us here in academia is that all of our work that we do needs to be documented and reproducible. And so using Python or code in general is a great way to enhance the reproducibility of your work because code is self-documented. You kind of already know what you've done. It's right there in the code. And so this is a great way to kind of remind your future selves what you actually were doing when you set out to clean your data. If you get a spreadsheet output and you open it up in Excel and you maybe do some clicking around and some cell manipulation and maybe some formulas and then you save it out again, there's really no record of that. And so Python is great because each one of the steps you do on your data is going to be documented and you'll be able to explain that later. Obviously, we have a lot of options for data cleaning. Excel, like I mentioned, is one of them, / also just a plain old text editor works too. There's a couple of applications that are free and open source. So OpenRefine and then R and RStudio. Those are two applications that we support here in Data Services, and they're also really great for data cleaning. OpenRefine is going to be more of your GUI, like your button pressing kind of data cleaning, and then R and RStudio are going to be code-based, similar to Python, but pretty easy to get started there. If you have any questions with those, I hope you'll reach out to me. A couple other applications that are licensed applications include Tableau Prep, which comes along with the Tableau desktop suite. And then also Stata and SAS are really popular data cleaning. Well, they're used for all kinds of things, but data cleaning is one of the things that they can do. And so we do have some licenses for SAS here in the Research Studio in Olin Library. And then Tableau Prep would be something that you could get through your Tableau desktop license if your department has Tableau available. Getting to the workshop materials. So we already looked at that folder. If I'll just reiterate here, pop out of my presentation just for a moment. Get there here, scooch this, there we go. So again, we have the workshop data folder, which please do go ahead and download that if you're going to be following along. And then we've got the notebook along with the PowerPoint presentation. So let me switch over to the notebook and we'll take a look at what that looks like here. Here in the room, has anyone ever used a Google Colab notebook before? Okay, great. We've got one in the room. How about on Zoom? Anybody familiar with the Google Colab notebooks? Okay, maybe not. Okay, great. So the Google Colab notebook is essentially just a Python notebook. So you can see in my Google Drive folder here, the file extension is .ipymb. So this is a Python notebook file that you can read either here in the Google Colab environment within Google Drive, or you can also open it using Jupyter Notebooks, which is a really popular platform for Python notebooks. And then also, if you are a GIS user within ArcGIS Pro, you can open Python notebooks in ArcGIS Pro as well. So really common format. You could download this .ipymb and you can open it up in the platform of your choice. It doesn't necessarily need to be Google Colab. The cool thing about Google Colab is that we're going to be actually running the code here in this web-based platform. So we don't have to download anything to our machines. We're just running it all within Google Drive. And so that's really handy, especially for instruction purposes like this. Okay, open in RStudio. I'm gonna say yeah, probably, Janine, on that. If anyone, I know we can run Python scripts in RStudio. If anyone knows the answer to that, maybe you could drop it in the chat for me, but I think maybe you can. So I'm gonna try that out and then I'm gonna report back, Janine, on that. So thanks for that question. Okay, so in the notebook here, what we have is these collection of cells, and cells can either be text cells like we're seeing right here, or if we scroll down a little bit, these cells here that have kind of the grayish background on my screen, these are code cells. So we can either look at text or we can run code. Now, running code is just as easy as clicking this little play button that's next to each cell. So just for kicks, if you're following along, go ahead and click that button. And once you click it, it may prompt you to log in with your Google account if you're not already logged in. But you do need to be signed in with a Google account in order to run these cells. You can also, with the cell highlighted, you can hit Control Enter to run the cell. So there's a couple of different ways that you can do that. What I'm going to have you do first is go through these little side icons with me. So if we click on the top icon, we're going to get the table of contents. And so this shows all of the sections that we're going to be hopefully getting through in our time together today. Whatever we don't get through today, I did design this workshop so that you can work through it at your own pace. And so if we don't make it to some of the sections and you wish to continue, all you need to do is follow along with my instructions there and you can work through it. The next icon here is a find and replace if you're looking for specific variables or keywords in your code. The next icon is the code snippets section, which is really handy if you need to do some operations that cover the entire notebook. So one thing that I use this for is after we start to run some of these cells, there's going to be output that that kind of like displays below each cell. And we might want to clean all that up sometime. And we could just say like clear or output here. And this will give us a little code snippet to clear out all those outputs. This is also a great way to kind of get little hints on what you might want to do with your code. So for example, pausing output processing. This is just the first one that popped up, but here's a little sample snippet if you're writing some code fresh. The next icon is the variables section, and I really like this one. Those of you that are familiar with RStudio will also be familiar with this, where once you start to set variables, they're going to appear in a list right here that gives you the name of the variable, the data type of the variable, and then information about the shape of that variable. So that can be really handy if you're wanting to keep track of the variables that you're producing in your code. Secrets is regarding authentication. We're going to just skip through that one right now. And then finally, files. This is where we're going to upload the files that we're going to use in our workbook today. So there's some sample data files that Google already provides for us here. But what we're going to do is we're going to click on the upload to session storage icon right here. And this is going to open up a file explorer window. I'm going to navigate to my download section where I downloaded the workshop materials for today. And I am going to essentially click the top file, hold down Shift and click the bottom file to select all of them, or hit Control A if you want. But the point is I want all the files selected. And then I'm going to click Open. There's going to be a little warning that says make sure you have your files saved elsewhere, because once we close this notebook, any outputs that we produced are also going to go away. So when we get some outputs, we're going to make sure we save those off to our machine so we have them for later. So you can hit OK on this error, or excuse me, warning, not an error. And then I can see I have all these files now available. So this means that my Python script can now access these files. When we run the code, we're going to access the files in a few different ways. Some of them we're going to access from the ones we uploaded here. And then we also are going to do an example of accessing them directly from a share link in your Google Drive. So we're going to kind of hit a few different options there. A few more things. So like I said, you may already have some experience with Python, but I kind of just want to make sure that we're all on the same page in terms of what Python is and what it means to have Python on our machines. So when you install the language of Python, which you can go to just python.org and install it on your own machine. When you install what we call base Python, there's going to be some built-in things that come along with it. So there's going to be classes, which are essentially the objects that are going to hold information and do work within our Python script. There's going to be built-in modules, which give us access to different pieces of our computer and different functionality within Python. And then there's going to be built-in functions, and functions are the things that actually run the instructions to do the work in our script. Now, going back to classes here, we have things like strings, integers, lists, tuples, dictionaries, and there's tons and tons of other ones. But all of your classes are going to have two important things associated with them. They're going to have properties, which are characteristics about the objects in this class. So the length of them, maybe what their size is, where they're located on your machine, and things like that. Then there's methods, which are built-in functions for this class. So again, they are things that are actually doing the work within the script. They're processing instructions, but they are associated with these classes in particular. So for example, the string class will have its own set of functions that strings are able to do for themselves. Okay, so when you install Python, okay, so now assuming all those things we just talked about, say they've moved over to this side of my screen here, and now along with base Python, there are like thousands of other third-party libraries that people have written that you can install also on your computer to go along with that base functionality. And so these third-party libraries are also going to have their own classes, modules, and functions, all that do specific things for that library. So examples of these include pandas, which is something that we're going to be looking at today, NumPy, which is for working with numbers and math. We're going to be using that a little bit today. And then ArcPy is a Python library that works along with the ArcGIS suite of products. And so these are all examples of things that you can go out on the internet and you can download and put on your own machine. Okay, now we've installed Python on our computer. See, here's our little computer here that we have. But we can actually have multiple instances of Python on our machine. So we can install Python 2, which is kind of the legacy version of Python. They're not making it anymore, or excuse me, they're not releasing new releases anymore, but it does still exist out there on the internet. And there are some libraries that are specific to the older version Python 2. So you could have a Python 2 on your machine. You could also have a version of Python 3. You could have multiple versions of Python 3 on your machine. So it all depends on what you have installed. And then also when you install certain applications on your machine, they may also install their own versions of Python as well. So it's really important to kind of get to know where Python is installed on your machine, how many instances of Python you have, because whatever you're going to be running the Python against needs to make sure it knows that it has access to these particular libraries. And so they're going to be different across your instances. And so that was one thing that when I started coding, it was kind of confusing. Like, what do you mean different versions of Python? And so getting to know where you're installing things is going to be key if you're going to use multiple versions of Python. Okay. All right, so I do have to say a little note on AI, of course. And so my note on AI is absolutely 100% use AI when you're writing code, all right? Now, AI is not going to eliminate the need for you to actually know what your code does, right? So you're still going to want to make sure that you have kind of that base knowledge. So when AI gives you a code snippet, you know enough to be able to alter it to do the thing that you want it to do. So I use AI all the time when I'm writing code, especially if I'm feeling like, oh, I know this is an easy thing. Let me just have AI write it for me real quick. I'll take that code snippet, I'll put it into my script, and then I'll adjust it a little bit to do the thing that I actually need it to do. AI doesn't always know exactly what you want it to do, so that's still up to you, but AI can be a great tool to kind of get you past the hump of not even sure where to start. And so I absolutely recommend using AI. And we'll see when we get into the Google Colab Notebook that AI is baked right in. And so it can be really handy in terms of error checking and writing fresh code to take advantage of AI within the cells here. All right. Okay, just a little bit on syntax, just to make sure that we're all on the same page here. So remember we were talking about classes, and classes have their own properties, which are characteristics of a class. So the syntax for a class property is the name of the class dot property. So for example, we have the data frame class here, a data frame object. And if we call data frame dot shape, then that gives us the number of rows and columns for that data frame, which can be helpful to know. Now, moving down to methods. So again, methods are functions that are specifically tied to a class. And that syntax is going to be the name of the class dot the name of the method, open and close paren, and then within the open and close parens are going to be 0 or more parameters, which are variables that we're passing in to the method. So for example, The string class has a method called replace. What it does is it takes in a string and it says, okay, let me find all the instances of this particular chunk of the string, and I'm going to replace it with the next, whatever I tell it to replace it with. So the syntax is going to be the string, the name of the string, dot replace, and then the first parameter is going, oops, the first parameter is going to be the string that you're looking to replace. And then the second parameter is going to be what you want to replace that string with. All right, so we've got the method and we've got a method that has two parameters here. And then finally, for functions, functions are going to be very similar to methods, except for functions are tied with the library itself. So for example, we have the pandas library, and the pandas library has a function called read CSV. It does exactly what you think it does. It reads in a CSV file. So that syntax is going to be the name of the library, pandas, dot the name of the function, read CSV, and then a single parameter for now, that is just the name of the file. So, okay, I'm going to read in this file, and that's going to be a data frame in my script being held in memory. So that's just a little refresher on the syntax because we're going to be using these a lot in the code. A couple of tips. When I'm writing scripts, I recommend setting all of your workspace paths and local variables at the beginning of the script so you don't have to hunt for them later on. Or if you're taking this script and you're passing it along to a colleague, they know that anything they need to set relative to their local machines or whatever is going to be set just right there in that first section. And so they don't have to worry about hunting for replacing paths and things like that later on. Definitely make sure you pay attention to data types. That's really important in Python because data types are going to be equivalent to different classes. And like we just mentioned, each class has its own set of properties and methods. And so we want to make sure that Python is reading a particular variable as we expect it to. So a string, an integer, a double, or whatever. Make sure you pay attention to the input files that you're bringing in and where any output files are going. That's a big one, not only in scripting, but really anytime you're using the computer. It's important to know, okay, here are the files that I'm actually using. And then when I saved that output, where did it go? And then depending on the size of your data set, I like to kind of work in a method where I add columns as I need to, and then right before I export my table, I narrow it down to only the columns I need so that my CSV will be kind of as small and as tight as possible. And we'll have a little example of that later on. Okay, so we're just going to talk about pandas really quick, and then we'll head into some actual code. All right, so the whole basis of pandas is the data frame. And so we're looking at an example data frame here. Essentially, data frames are just in-memory tables. And so each table obviously is going to have a number of columns, which in pandas speak, they call those series. And then each row is just going to be a row. And then also behind the scenes a little bit, every single row is going to have an index value starting at 0. And so this is just kind of how Pandas keeps track of all those rows. And then each one of these columns will be a series, which we can work with individually. Okay. So now we're going to head over to the notebook. Before we start running the code, what questions do you have either on Zoom or here in the room before we actually start running the code? In the R code from ChatGPT is often very inefficient, producing very long and unnecessarily cumbersome code. Is Python the same? Absolutely, yes, it is. That's why, again, AI does not remove the responsibility of us from actually knowing what our code does. All right. It will give us a hint, but it's not going to do everything for us yet. I mean, it is getting better and better every day, but we're not quite there yet. I've also found that using ChatGPT or any other built-in AI, sometimes it really is hard to get the point across of what you're doing, and so it can take several iterations, or they might want you to use libraries that like you don't have access to and things like that. And so again, it's not perfect, but it can give you a little bit of a leg up or a hint if you need it. Thank you for that question, Janine. Okay. All right, so let's get into it. So we already loaded our data files into the notebook, and I'm just gonna expand my little files icon to make sure that they're still there. And so the next step is we're going to import our libraries. So we already ran this cell to kind of test us out, but just to give you an overview, so the OS library, this is a built-in library, so we didn't have to install it ourselves, but we do need to actually run this import statement to make it accessible to our script. So of the libraries that we're seeing here, the OS and the sys libraries, or excuse me, I guess they would be built-in modules. They're already in base Python. We do just need to import them. The pandas and the NumPy library, those are third-party libraries. And so if we were working on our own machine, we would need to install those separately. Luckily for us here in the Google Colab notebook, they are already installed in the environment, so we don't have to do anything extra. All we need to do is import them. So we're doing an import pandas as PD, which means that any instances of pandas later on in our script, we're going to just refer to it as PD, not pandas all the way written out. And then the same thing with NumPy, we're going to refer to that as NP. So we ran this cell, we didn't get any errors, so we can just move right along because all of those libraries are imported into our script, and now the functionality of those libraries will be available to any cell within this notebook. Next up, we're just going to take a look at the version of Python that we're using. So remember how before I mentioned we could have multiple versions of Python on our machine. So sometimes it's helpful to know what Python version we're using. And so if you just use print, and then from our sys library, we're going to use .version. That's the property that tells us about the version of our Python instance. This tells us that we're running version 3.11.11, and we can see that this was released back in December of 2024. So it's a pretty fresh version. I would imagine probably in the next month or so, we'll probably be seeing a new version of Python out, and eventually Google Colab will incorporate that into the environment. But for now, that's what we're working with. Next up, we're going to create some variables that are going to serve as our local file names. So we've got three that we're going to talk about here. The first one, data file name 1, this is just the name of this sample survey data CSV. And let's just take a quick look. I'm just going to pop this open. You don't need to do this, but I just want to show you kind of what is in this CSV so we know what to expect a little bit. And it's pretty simple. We just have a handful of columns with a case number, a city, a state, a zip, and an income. So we can imagine that maybe someone sent out a survey for people to list their income. And these are all of the results that came from that survey. Okay. All right. Next up, we have data file name 2. And so this is the example where we're going to bring in this file, not from a local file, but actually from a file we have saved to Google Drive. So this URL here is actually the sharing URL for this file in this workshop data folder right here. Okay. And so we both have the file here, but we are going to access it via Google Drive. And so that's why data file name 2 is the sharing link for Google Drive. And then data file name 3, this is the prefix for the NAICS_4451 sheets. So we've got 5 sheets that have that prefix, and that is information that we're going to use to read in multiple files a little bit later on, because sometimes not all of our incoming data is one file. Sometimes it's multiple files, and we need to merge it together into a single data frame. Okay, so I'm going to run this cell that's going to give me my variables that are representing my file names. If I go ahead and pop open my variable window here, now I can see I've got three variables. They're all strings because they're just names of files, and then it gives me the number of characters. So this list is going to start getting bigger as we go on. For now, though, I'm going to close that pane so I can have the maximum real estate here on my screen. Okay, so let's go ahead and use that read CSV function to read in our local survey data file here, data file one. So to do this, I'm going to set a variable called data, and to put information into that variable, I'm going to use the pandas.readcsv function, inserting that file name to have it read in that first file. So if I click that, no errors or anything, that's good. And so just to make sure that everything is looking okay, we're going to look at some information about this particular data frame. The first thing we're going to do is look at shape. So again, that's the number of rows and columns, and the output of that is going to be a tuple, which is a specific data type in Python that is immutable, meaning that we cannot change around the elements of this tuple here. They're kind of fixed in stone until we recreate the tuple. So this tuple is telling us that our survey data has 1,068 rows and 5 columns. We can use the .head method. So name of the data frame .head, open close parens with no parameters in there to see the first 5 rows of the data set. And so this just kind of gives us a little indication that yes, the data set was read in there properly. Next, we're going to look at count. So data.count, open close paren. So this tells us, again, this is a method associated with the data frame object. So here are each of the 5 columns. And so it's telling us that in all of the columns except for income, we basically have values in all of the columns. So it looks like we do have some nulls in the income column that we're going to have to take a look at. Next up, we're going to use the data.describe method. And so what this is going to do is give us some summary information on the numeric data types coming through in our data frame. So this is interesting because right now, neither case nor zip code are columns that we want to be treating as numbers. We actually want to be treating those as text or categorical variables because the number of case number and the number of zip code doesn't really mean anything to us. They're mostly categories. But by default, the .describe method is going to take only the numeric types and give us summaries on those. So the count of the records, the average value, the standard deviation, the min and the max, and things like that. Now, if you want to force the describe method to include all of the columns, you can use the parameter include equals all. So we're still starting with the data frame here. We're using the describe method, but in this case, we're listing one parameter, the include parameter, and we're setting that include parameter to all. So when we run it now, it's going to give us all of the columns in our data frame. And you can see that the ones that are obviously text, it can't give us the mean and the standard deviation for because that doesn't make any sense. But again, it has given us those numeric summary values for case number and zip. One cool thing about this is that if we look in the city column, we have 7 unique values for city, we have 1 unique value for state, and so on and so forth. So that might be kind of handy to know how many unique values do we have in those columns. And then finally, we can also use describe and isolate only specific data types that we want. So still using the include parameter here, only this time, instead of setting it to all, we're actually importing a list. So a list in Python is surrounded by square brackets here. we're importing a list with only the data types that we want it to show. So for example, object data types. Now, object data types are going to be kind of like a mixed case data type. It basically means that Python is not sure if it's a string or a number or how you want to slice it. And so it kind of just throws things into this object data type. And so later on, we might need to actually force these and say, okay, these are strings, these are numbers, and so on and so forth. But this is just kind of practicing how you can swap in different parameters in your methods. So for our cleaning steps, let's imagine we have this survey data here, and we need to do some steps on this survey data to make sure that we can use it in our analysis. So for my particular project here, I need all of the zip code values to be strings. I need all of the income values to be numeric because I'm going to do some numeric analysis on my incomes. And so those have got to be read as numbers. I want to make sure that all of the names of the cities are valid and also consistent, meaning like we don't have 5 different ways of spelling St. Louis, which is pretty common for us here in St. Louis. And then also, I want to make sure that I can take this table and join it to another table that I have that is data by zip code, so I can match records in that way and join 2 tables together. So those are kind of like my goals for the project at hand. Is the dot the same as the dollar sign? Yes. So most of the time, the dollar sign in R is letting us specify a specific column. And so that is the same in some instances in Python. Most of the time, though, what we're going to be doing is we're going to be referring to our columns in the square brackets like this. So in R, this would be data $zip. In Python, we could either say data.zip or we could say data open close parens zip to specify a specific column or series. So that's going to be specific to pandas, how you specify a series, but these can be used interchangeably, a dot or a zip. I think in my code, though, I think I'm using all of these square brackets. Janine, though, this is not the same as like data dot D types. That is not the same. So the syntax for R, while structured similarly, those little things about the syntax, that's what's going to be different. And the dollar sign to specify a column is one of those. Awesome. Thank you. Keep those questions coming. Okay. So again, let's look at the data types of our column. So we're going to introduce a new property here. This is the dtypes property of the data frame. So I'm going to call data.dtypes, and it's going to give me a little list here. It's saying that it's recognizing case number and zip as integers, 64-bit integers. City, state, and income are all objects. Okay. So it's an okay start, but Python is literally not seeing anything how we want it to be seen. So we need to do some forcing and some instructions so Python knows what we're dealing with here. So the first thing we're going to do is we're going to take our zip code column, which is coming in as integers, and we're going to convert the zip value to a string. So the syntax for this essentially looks like we're going to be replacing the existing zip column. So what this says is take my data frame and create a column called zip. And in this column, here's what you're going to put in it. You're going to take the existing values of the data.zip column, and you're going to run this as type method on them. And the as type method, we're going to pass in one parameter, which is string. So this is saying, take all of my zip code values, and I want you to replace those numeric values with strings. So we're going to run that code. We get our little green check mark. Let's take a look at the data types again. All right, so now we can see that the zip code is specifically a string now. It's not object. It's not kind of a mixed case. It's a full-on string, and so Python will treat those values as strings along with all of the other cool stuff that we can do with a string, like replace. All right, so our first bullet point, check, we have checked it off. All right. Now let's look at the income column. So we know that the values are being interpreted as the object data type or the mixed data type, and we need these to be numeric. So just for kicks, let's go ahead and let's look at all of the unique values of income, because sometimes I kind of just like to look and see what my range of values is. So to do this, we're going to start a loop, and we're going to loop through all of the unique values and print them out. So the syntax for that in Python starts with the word for. We're going to do a for loop. And so what we're going to be looping through is the income column dot unique. So all of the unique values in the income column. So looking at this specifically, we have the series, that's a Panda object series, which is the column. We're going to be calling the dot unique method on that series. So dot unique, open, close parens, and all that is doing is just going through and finding all of the unique values there. So once it finds all the unique values, it's going to loop through them. Each iteration, the value is going to be the variable v. And so when it loops through all the values, all it's going to do is just print out that v, which is the value in the list. So if we run that, we have a huge long list of values here. And my whole point in going through all this is because I want to find, oh, wow, that's going very fast. I want to find anything that kind of like looks amiss to me. So all of these look good. All these look good. Let me scroll down a little bit here and scroll down here. Oh, there we go. Check this out. We have a value of St. Louis in our income column. Okay, well, so we know that that's wrong. Let's see if we have anything else that looks interesting here. We should also have maybe a null or two. Let's see if that pops out. Okay, I know we have some nulls in there somewhere, but the key that I wanted to bring up here is that we are seeing a St. Louis value in there. Now, I have a huge long list of values here. I don't want this cluttering up my screen, so I'm going to right click in the cell here, and I'm going to say clear output, and that's just going to clear that output away. The cell is still run. It's just not displaying that output anymore. Okay, so we went through our list and we saw that the value of St. Louis is invalid. There also was a none in there too, but we want to make sure that our none is recognized as a null value. So we're going to convert these values using the same method we did before, the as type method. So essentially what we're doing here is we're taking the income column and we're replacing it with the same values from the income column. We are just indicating that they're going to be an integer. So let's see what happens there. Okay. All right, so we're getting an error here. So this is a great example of what errors look like in these notebooks. And so it's going to tell us where the error was thrown. So it was thrown right here on this line, and it'll give us some information about what the error actually is. The headline here is going to be down at the bottom. It cannot convert float nan to integer. So basically what it's saying here is those none values, it can't convert that to an integer. So we need to try something else. Let's try that again, only this time let's use a different function. So this is actually going to be a function associated with pandas. And so what we're doing here is we're taking all of the values in the income column and we're using the pandas.toNumeric function. And what we're going to do is we're going to pass in a series or a column into that function. So we're saying take the values in income, and we're going to take those existing values and we're going to convert them to numeric using this toNumeric function and replace the values that are currently there. So let's try that and let's see what happens. All right, so we're getting another error here. Now it's a different error, which is good. So it means that maybe this took care of the null values error. But now it's telling us that it's unable to parse string St. Louis at position 1058. Okay, so since we've got that text value there, we're not going to be able to use this two numeric function just as is. We might need to mess with it a little bit just to get that to work. All right, so let's see what we can do here. We're going to try again. We're going to stick with that two numeric function here. And this time we're going to do everything the same. We're going to pass in our income values. We're going to use pd.toNumeric. Only this time we're going to introduce another parameter, and this is the errors parameter, which specifies what you want Python to do with any errors that it encounters. So the value course passed into the errors parameter is going to take anything that's going to be invalid, anything that's going to throw us errors, and it's just going to change that to null. And so that's great because that's actually what we want it to do, because the value of St. Louis, it's not going to help us at all. So let's just make that a null because it doesn't make any sense to us right now. So I'm going to run this cell here. I didn't get any errors, so that's good this time around. And now if I run that same loop that prints out all the values, I can see they've been changed to numeric here. And if I were to scroll through this whole list, we would see that NaN or NaN, which stands for not a number, essentially indicating that the value is null. All right. So if I could just scroll through this real quick, maybe I can find it. If not, we'll just move on because there's like a lot. Oh, there it is. There we go. So now we have NaN or null as a value in our numeric columns. Okay, I'm just going to clear that output. What questions do you have about those data types and changing the data types? Hearing and seeing none, we'll move on to messing around with our cities, because this is going to be something that we have to do a lot in our work. And especially if we have free text responses, we're going to have people putting any old thing in there. And so we need to learn how we can make these values valid and consistent. Okay. So in our city column, let's take a look at the values here. Now, going back to Janine's question, this is another way to refer to that column. So previously we were using the square brackets with the name of the column in quotes. This is the same as this. So we're just kind of showing two different ways that you can access the series or the column. So in the city column, let's go ahead and let's look at all of the unique values in city. If I click that, the output is an array or a list. And it tells us, okay, we've got 1, 2, 3 different instances of the city of St. Louis. They're all spelled differently. We've got some Kirkwoods. We've got a U city and we've got a university city. So we're going to need to deal with that somehow because we want one consistent value for that location. And then also in the city column, you can see that we have a Mo in the city column. And so I can only assume that that was a data entry error, and really that Mo should not be there. It should be a city. Okay. So we're going to take a look at U City first. So it might be helpful to know, okay, how can we just create a brand new column in our data frame? And so this is just a quick example. If we want to create a new column called country and we want to populate it with the same value all the way down across all 1,068 records, all we do is we call the data frame, we open close parens with the name of the new column. Now, Pandas is going to recognize, oh, this column doesn't exist. So what you must be wanting me to do is create a new column. And so that's what it's going to do. And it's going to populate all the values with USA. So let's run that. And just to double check, we're going to use that head function associated with the data frame, or excuse me, that would be a method associated with the data frame. And we can see that we've got country now with USA completely populated. So we can use this same method to this time create a new column that we're going to call corrected city name. And so we're going to be using the replace method associated with the string object with these two parameters. We have our to replace parameter, which is the string we want to replace, and then the value parameter, which is the string to replace with. So in this next line here, the syntax, we're going to create a new column called city corrected in our data frame. And in that city corrected column, what we're going to do is we're going to insert these values. We're going to take a look at the existing city column and we're going to replace something. What are we going to replace? We're going to replace any values that are equal to U space city. What are we going to replace them with? We are going to replace them with University City written out. All right. So right now we're only tackling U City. So those are the only ones that are going to be done in this city corrected column. So I'm going to run that. If we take a look at the unique values again in the city corrected column, we'll run that. And so now our array has gone down a little bit. We're still seeing our St. Louis's, but now we're only seeing one value for University City. So we're on our way. There's another way that we could do this, or that we could like look at these values if we wanted to specifically check out the values that we've changed. We could create a new variable where we're going to take the data frame, and then what we're going to do is we're going to filter out the records that are equal to U City. So we're introducing some more square brackets here. So in our data cleaning work that we've done so far, we've done a lot of work with square brackets already. We've looked at square brackets as indicating a list in Python. We've looked at square brackets indicating a series here. And this instance of square brackets indicates a filter. So when you put the name of the data frame and then square brackets with this expression in between the brackets, this essentially gives you a filtered set or a subset of the original data frame. So what this is saying is take my city column and find all of the records where city equals U City, or, and that's the little pipe here indicates the operator or, to go to city and give me all of the records where city equals University City. So this is going to give me everything where the original value of city was either U City or University City. And then I can check that and I can make sure that all of those values in the corrected city column now are equal to University City. So I'm going to run that, and then immediately I'm going to call that head method to give me the just the top of that particular data frame, the top 5 records. And I can see here that I had some U cities that were transferred to University City, and then I also had some University cities that are also University City. All right. So what I'm trying to do here is I'm just trying to give you examples of how you can kind of slice and dice your data to confirm and validate the code that you've run and make sure that it's actually doing the right thing. All right, so next up, we also saw that there was a value of Mo in the city column. So let's see if we can check out that specific record. So here, I'm going to use the same kind of filtering / subsetting strategy that we did up here. Only this time, I'm going to say, take the data frame, and then I want you to filter out only the records where the city column is equal to Mo. Now, this actually brings up something else in my mind. A question that I get occasionally is what are we doing with these double equal signs here? So we've been using equal signs as just one plain old equals here, which basically indicates an assignment. So we're taking this variable name and we're assigning it this value. When we have the double equal sign, that indicates that we're actually comparing two things. So we're saying, does the values in the city column equal to Mo? If it does, great, we're going to spit that out as one record in our new data frame. And if it doesn't, we're just going to move on to the next record. So when I run this code here, I can see I have a data frame that has just one record, and it's that one record that we saw. Um, the income is set to null, so that tells me this was probably the record that has St. Louis in the income column, which we know is incorrect. It looks like we're also seeing Mo for both the city and the state. And so we are going to need to correct that because this city should obviously be St. Louis with this zip code. So let's see how we can do that. Okay, so what we're going to do here is we're going to again use the strategy of how we essentially replace the values in an existing column with new values. We're going to say take all the values in the city column and replace them with the following, which is anything in the city column where the value equals no Mo, so the value that we're replacing equals Mo, we're going to replace it with the word ST period space Louis. So we run that. And now, okay, so this is a little bit of a cheat. We know that the case number here is case number 1059. So just in the interest of time, I'm just going to say, okay, let's look at this specific record, case number 1059. And we can see that now the city has been replaced with St. Louis, Mo. The zip code looks correct, income is null. And so really this record has been corrected and we're ready to move on. All right. So let's apply that same method. So previously with uCity, we created that new column called corrected city because we wanted to look and see how we could create that new column. This time, let's go ahead and use the same strategy to replace the values of uCity in the city column with University City. So we're essentially doing the exact same thing, just replacing the to replace and value values there in those parameters. We'll take a look at the unique. And now we're good. Mo is gone from our list of uniques. University City is there. Kirkwood is there. And then we still have our 3 St. Louis's that we need to deal with. Okay. All right. So we certainly could, since we're only talking about 3 different instances, 3 different versions of the word St. Louis, we certainly could just use the same strategy and say, okay, replace ST without a period and put the period in and so on and so forth. But since we're experimenting, since we're learning here, what I would like to introduce you to is something called regular expressions. Anybody familiar with regular expressions? No? Okay. If you are familiar with regular expressions in Zoom, go ahead and give me a thumbs up. Else, we will take a look at what this even means. So regular expressions are essentially like wildcard searching, but much more complex. All right. And so in the notebook here, I give you a link to W3 School's regex page, which is just a good way to kind of get to know what regex is. But essentially, regex is almost like its own little mini programming language in itself, meaning that certain characters are going to be represented by certain symbols and so on and so forth. So we could certainly do like probably a whole day-long workshop on regular expressions, but I kind of just want to introduce you here so you know that these are something that you can use if you have more complex patterns that you're looking for. And so in the slides here, I'm going to go through what we're actually going to do to find St. Louis. So in our all of our values of St. Louis here, they were all something something space Louis. All right. So we know we can kind of harness that and look for the word Louis to indicate, okay, this is a value that I need to change to ST period Louis. And to do that, we stick kind of a series of characters in front of the word Louis. So the asterisk symbol here at the beginning means that all of the pattern within the parentheses here must be at the beginning of the string. All right. Sometimes that's necessary. You want it to be at the beginning. Sometimes it's in the middle. Sometimes it's at the end. Regex has ways of specifying that. And so regex, the caret here means, okay, this has to be at the beginning. Then anything in the parentheses is at the beginning, and here's what could be in the parentheses. It could be any character and then any number of previous characters. So what this is saying is if there's anything that starts with something and then ends in Louis, then that's going to be St. Louis, and we want to replace that with the version of St. Louis that we want. So this is a lot of characters just to indicate that, but this is kind of a you know, it's a little bit more of an advanced example of using regex in this way. Most of the time, you know, you're just like switching out digits and white space and stuff like that. But this is getting a little bit more complex, basically finding anything that is something at the beginning, and then Louis, we're going to assume that that is St. Louis. Okay, so back to our notebook. The first thing we need to do in order to take advantage of regex within Python is we need to import the regex built-in module. And so again, this is not something we have to download, but we do have to import it into our script. Yes. So question on Zoom. If you just have the asterisk and then the dot, would it signal that you were only looking for one character before Louis? And Nicole, I think the answer to that is yes. But let me show you how you can check. So in our text here, I also give you a link to this site called Regex 101. So if you open up this, here's the way you can test this. So we know that here's all of our unique examples of St. Louis here. So I'm going to take those, Regex 101, and I'm going to drop, oh, come on. There we go. Oh, no, not that. Let's see. Let's try this again. We're going to take our array. We're going to drop it into our test string area here. All right. So since we already know that this pattern works, let me drop this pattern in. So this is just the same pattern we were just looking at on the slide, just in the code this time. And I'm going to get rid of these little things here. Okay, so what you can do is you put your expression here in the expression box, and then your test string down below, and then it's going to highlight the strings here. Now, what's interesting is I must have maybe put this one, maybe I need to put this in quotes now, because now this is catching this one. Oh, you know what? It's because it's not at the beginning of the string. That's why. Okay, so if we just kind of get rid of this here. Okay, there we go. So what this is saying is it's saying, okay, here's your expression. Here's all of the strings that are going to get caught in that expression. And so since at first, since some of them weren't at the beginning of the string, that's why they weren't getting caught. But now that all of these are at the beginning of the string, then they're getting picked up. Now let's do Nicole's experiment. Let's see if we were to get rid of the any character indication and just put one period, none of them get picked up. So I think that does tell us that yes, the single period is just saying one character, not any number of characters. So that's a good question. This is just kind of a way you can work through your regex in like a regex 101, or there's actually many of these kind of like regex tester websites. And so this is a good way that you can go through and try that out. Okay, awesome. Yeah, thanks for that question. And again, keep the questions coming because chances are if you have that question, other people have that question, and let's talk about it. Okay, so we imported our regex module now. Okay, so now what we're going to do is we're going to set our pattern. So we're going to use within the regex library here, we're going to use the compile function. And what we're going to do is we're going to pass through that regular expression. Now, I do have to wrap the regular expression with single quotes, or probably double quotes would work too. But we do have to pass it through when in quotes so that it knows, okay, here's the expression to actually evaluate. and we're going to set that expression to a variable called STL pattern. So let's run that. Again, I kind of like to know what data types I'm dealing with here. So I'm curious, like what data type does Python think STL pattern is? And we can use the built-in Python function type, which is going to tell us the data type of a specific variable. And so this is telling us that this is a object within the regex library, and it is a pattern object. So it's recognizing this as a pattern that it's going to be looking for in our text data. So now that we have this pattern entered in as a pattern, we can go back to our very familiar replace function that we've already used before. And in this case, what we're going to do is we're going to take the existing city column. And what are we going to do with it? We're going to take the existing values. We're going to use the replace function. What are we looking to replace? We are looking to replace STL pattern. So any instances of anything space Lewis, that's going to be our pattern that we're going to find. What do we want to replace it with? We want to replace it with the value st period space Lewis. Let's say on our project team, we have agreed that we're going to always refer to St. Louis as st period space Lewis. And so that's what we're going to replace it with. And then the other thing, and the difference between this and what we've done before, is we do need to go ahead and set the regex parameter to true. And so this indicates to Python, oh, you're actually looking for a regex expression here, not the literal like period asterisk question mark, like we're doing a regex here. And so this regex property indicates that. So I'm going to run that. And let's take a final look at our unique values. And this is looking much better now. We've got St. Louis, we've got Kirkwood, and we've got University City. So all of our St. Louis's are correct, and we're ready to move on to the next thing. Okay, so next up is the final step in our list of things we needed to do, which was prepare this table to join it to another table. All right. So in this section, we're going to be taking this existing table, and what we want to do is we want to join it with our second file, which is the file we named data file name 2. And so just as a refresher, data file name 2 at the beginning, we did set it to this link, which is the sharing link of the file in Google Drive. So what I mean by that is when you're in Google Drive and you just click on share here and it says, okay, copy link, that's the link that we're using for this. Now we're going to have to do some manipulation on that link to get the file to be read in, but that's at least where we're going to start. All right, so the first thing we're going to do is we're going to split up this URL, because what I'm really interested in here is not necessarily this whole URL. What I really want is this string of characters right here, which is the unique ID for this particular item in Google Drive. So that's really what we're after. I don't care about any of this stuff or any of this stuff. So what we're going to do is we're going to use another string method here, and this is the split method of strings. And so what it does is it takes a string and it splits the string or divides out the string based on whatever character you tell it to split at, and the output is going to be a list of that string chunked into the different chunks based on whatever your delimiter string is. So in this case, what we're doing is we're creating a new variable called URL split, and it's going to take the data file name 2, which is this string here. It's going to run the split method on it, and we're inserting one parameter, which is the forward slash. So we want the string to be split so that every chunk within these forward slashes here are different elements in our list. And then just so we can see what we're dealing with here, I'm going to print out that that split list. So here's the list. We know it's a list because it's square brackets. And then it took this chunk, and here's the first one. Then it took kind of the space in between, and it's that one. And then it just dropped those in. So basically this string right here, which is the item ID, that is the second from the end element of this list. Okay, second to last element is the unique identifier. So what we want to do is we want to retrieve this unique identifier and then insert it into a download link so that Python essentially acts as if it's going out there and downloading the file, but essentially what it's going to do is read the file in as a data frame. So we need to know, and this is something that, if you just do a little Googling, this is the beginning part of the download link. When you click download in Google Drive, this is the link that uh, the web page goes to. It's this little prefix plus the item ID. So let's see how we're grabbing that. So we have a string that represents that first part of the URL. And to that, we're going back to our URL split list. And here we have those square brackets again, which we're using in yet a different way now. And this is square brackets indicating the index value of the item in the list. So in lists in Python, each element has an index starting with 0. So this element is going to be index 0. This element is index 1. This element is index 2, and so on and so forth. We know that the item ID is the second to last item in this list. So it doesn't matter how many items there are in the list, it's always going to be the second to last one. So we do that by giving an index of -2, which means start at the end of the list and then go 1 to end, and this is the element that you want. So this is basically a negative index, which means instead of starting from the front of the list, I want you to start from the back of the list. So then we grab that element, we add it to our full string here called URL, and then we should have a URL that is the download link for this item. So let's run that. It's going to print out a URL. Now you don't need to do this, but just by way of example here, I'm going to click on that link, and just to check to make sure everything's working okay, it started to download that file here. Well, it actually did download that file. So I know that this link is working properly. It's downloading this CSV here. We actually don't want to download the CSV. We want to read this in directly. So what we're going to do is we're going to take that URL that we created here, and we're going to pass that URL into our read CSV function. And this essentially reads the CSV file directly from Google Drive and makes it into a data frame. So we're going to create a new data frame called demographic data. We're going to create that by using our pandas.readCSV function and passing in that URL. So let's click on that and we'll look at demographic data. This is just printing it out, and it's giving me basically the whole sheet here. We've got a zip code column, a population column, and so on and so forth. But the key that we're looking for here is the zip code column, because that's what we're going to join our other table to. All right, so I'm going to click and I'm going to clear output, and we're good to go there. Okay, so we know that in the previous section, we converted our zip codes to strings. So whenever we're doing any joins, we need to make sure that the data types of the fields that we're joining on are the same. So we need to make sure that our zip codes coming in from this table are also strings. So I'm going to take a look at the zip code column here just by isolating it using square brackets. And this gives me like the whole output here. And at the bottom, it tells me that this is coming in as an integer. So again, we need to do some steps to change this. All right, let me just do that output, clear output. All right, so we're going to create a new column. This one's just going to be called zip, and we're going to use that as type method on the series here, the series called zip code, and we're going to convert it to a string. So again, creating a new column called zip by taking the values from zip code and transferring them to strings. And so now if we take a look at our dtypes property, we can see that zip code obviously is still an integer because we created a whole new column. Here's our new column called zip, which is indeed a string. All right, so we want to make sure we use that zip column and not the zip code column to join on. All right, so now we can merge the two tables, all right? So there's a merge function in Pandas, which is really, really handy to join two tables based on a common identifier. But we do need to know a little bit about joins. We want to make sure that we're using the right join type. So let's take a look at a little review of joins in our presentation so we can make sure that we're doing the right thing. Okay. So say we've got two tables here. We've got table A, which is a table with some author information, along with a unique identifier for the authors. Then we have table B, which is a table of books. So each row is a book that exists here. And the table B has an author ID column, which links back to the ID of the author in table A. So there's four major join types here. We have a left join, which will give you all of the records from table A and only the records from table B that match based on your join field. The opposite of that is a right join that gives you all the records from table B and only the records from table A that match based on your join column. You have an inner join, which is only going to give you the records that match between tables A and B. And then you have a full outer join, which is going to give you all the records from both tables. And then the ones that match will be joined together. And so let's take a look and see what those look like in practice. Back to our tables A and B. So if we do a left join, it's going to give us all of the records from table A here and only the records from table A that matched. So we can see that in our table B, our book table, we did not have any records by the author Emily Stevens. And so we have a null here for that particular row. So that's a left join. Next up, we have a right join. So we're taking all of the books, we're matching them up to their authors here, but we can see that the book Modern Art did not have a corresponding record by ID in table A. So we're getting null values here because we didn't have a matching record for the author. An inner join is where the output is only the records that match. So only the three records that existed in both tables are output here. So just these three records that had books that matched in the book table. And then finally, the full outer join basically gives us everything, and the records that don't match will just be null. So Emily Stevens is not going to have any records for book title, and the book Modern Art is not going to have any information for author because it didn't exist in our table. So that's just a little quick refresher on what the join types are, okay? Which I always forget them, and so I always need to go back and like figure out which one I actually need. So it's worth kind of like mentally, maybe even drawing a little picture to figure out like, okay, what join type do I really need here? In this case, what we're going to do is we're going to do a left join because we're going to take all of our data from our survey, and then we're going to join it up with the information from our second table by zip code. So only the zip codes that match in the second table will have values in our output table, but all of the records from our first table will be there. We indicate this to Pandas with the following. So we're going to create a new data frame called data with demographic. To do that, we are going to use the merge function, which is part of the Pandas library, so pd.merge. And then here's the parameters. So the first parameter is going to be the first table. So essentially this is going to be your table A. The second parameter is the table you want to join. So this is going to be your table B. What do you want it to join on? Well, conveniently, when we created the new zip code column, I called it the same thing as it was in the first table. So the first table has a column called zip, that's a string. The second table has a column called zip, that's a string. And so I can just say for both tables, use zip, and that's what you're going to be using to join. And then finally, the how parameter is where we indicate what kind of join we want it to be. So this is going to be a left join. We're keeping all the records from table A and only joining the records from table B that match by zip code. All right, so let's run this. We'll look at our output here. I just printed that out below. So we can see we've got all 1,068 records from table A here. We can see that some of them matched, okay? So we're getting values from table B coming in here. But we're also seeing that there are several records that did not match, meaning that they did not have a corresponding zip code in our table B. And that's fine. But really, we're really not interested now in the records that don't have any values here. So let's figure out how we can isolate only those records that had joins. So what we want to do here is we're going to create a new data frame called join matches. And here's our square brackets again. And in this case, we're using them to filter out our data set. So we're basically doing like a little selection here. And we're saying, okay, to join matches, what I want you to do is I want you to go with the data with demographic data frame that we just created here. And then here's how I want you to slice that up. I want you to take all of the records in zip code that are not NA. So not NA, this is a little, this is going to be a method associated with the data series zip code. And what the not NA method does is it returns any records that are not null. So we're not doing like equals equals sign not null or anything like that, or not equal to null. There's kind of this built-in thing that says if it's not null, then that's what I want. So join matches here essentially should be a much smaller table that includes only the records that had those zip code joins. So let's run that and let's see what happens. Okay. So looking at this table, now I can see that all of the stuff from all the stuff from table A came in. Here's all the stuff from table B, and now here it is in one nice big data frame. Okay, great. So I think that we've checked off all of the uh, items that I wanted to do for this particular file at the beginning. Now maybe I want to take this into some other application because I'm going to do some analysis on it or whatever. Maybe I'm going to continue doing it in Python or R or whatever. So we're going to want to output this to a CSV and kind of take it with us. And remember, I said at the beginning, any files that we output here are only going to live in this notebook instance for this time. As soon as we close this tab, those files are going to go away. So we want to make sure that we grab all this work that we did. So I'm going to create a variable here called output file. The value of this variable is just going to be the name of the file that I want to export. Then I'm going to use the toCSV method of the data frame. So here's our data frame. It's called join matches .toCSV, and then one parameter, which is just going to be output file, the name of the file that I want to output. So I'm going to click on that, no errors, so it looks pretty good so far. Let's take a look at our files list, and sure enough, now I have this survey joined to demographic data item here in my files list. Now, if I double click on this item, it actually shows me a preview of this file right here in the web interface, which is great. It lets me look and just make sure that things kind of look okay for me. And one thing that I am seeing is, remember how we talked about the index here? This kind of unnamed column here, that is the index. And so sure, it's important kind of when we're working in Python, or excuse me, in Pandas to know the index, but say the application I'm going to be using next, it doesn't need an index. And so I don't want that to be part of my output. Let's see how we can do that. I'm just going to click the tab actions and say close tab for now. I'm also going to close my files list just for the time being. And so um, removing the index from the output is no big deal. All you have to do is do that same output to CSV method here, only say index equals false. So this is going to output that CSV without the index in here, and then I can just double check. Okay, yeah, now sure enough, the case number is the first column there. So far so good. We're looking great. What I am seeing though is, remember all those random columns that I created, like country and city corrected and all that? Like those are still there, and that's not really necessary for the next step of my analysis. So let's see how we can isolate just the columns that we want. Okay, so we're going to go down to the next cell here. Okay, so what I'm going to do first is I'm going to take a look at all of the columns that are in my data frame first. Then I'm going, in that column list, I'm going to use the remove function. Excuse me, this is going to be the remove method associated with the list. And I'm going to remove the value of city corrected from that list. And then I'm going to print the list out again. So let's see what happens here. So here's the first list. And it has all of my columns in here. Okay, that's good. Now I ran the remove function, remove method, and then I printed out the list again. So now I have that same list and I can see that city corrected is removed. Okay, awesome. So then I can take this list here, call list. I can go back to my to CSV method here. And so again, we're going to say to the output file, I want you to have the index of the index be false, so no index. But in terms of columns, I only want you to output the columns that are in this list. So if I run that, I open up my files list again. I take a look at my output. And so everything's looking good so far. And when I scroll across, I can see that my city corrected column is indeed gone. And so now I'm feeling good about this. So then the final step here is to find the output file in my files list, click on my little more options icon, and click download to download the file. And that's how you can make sure that you're taking this work with you so you can use it for something else. Okay. So now we're kind of moving into a little bit more of like the bonus content section. So my plan here is to just kind of get through everything I can. And then everything else in this workbook is kind of like walking you through step by step, just like I'm doing now. So whatever we don't get to here before this workshop is scheduled to end at 3 o'clock, feel free to just continue on and do this as you have time. But we're going to kind of just work through any chunks that we can get through now prior to running out of time here. And if you do have to leave, feel free to leave. I won't be offended or anything. We're going to just kind of move right on through. But I am here if you have any questions. Okay. So sometimes the output that we get that we need to work with is all in one nice, neat file, and that's great. Sometimes we can join two files together, and that's also fine. But sometimes, especially if we're doing something that's more like longitudinal, where we're getting like outputs every month or something like that, slash sometimes in the case of these particular files, I pulled these from a application of business information that we have here at the library. And when I'm downloading, I only have the ability to download like 100 or 200 records at a time. And so we might have like multiple files that we need to combine. And so we're going to start off switching gears to our other files here, these NAICS files. We're going to combine all of these because I want to look at all of this information all as one data frame. So I'm just going to pop open one of those files. Let's see what they look like here. And what it is each record is a listing of a grocery store. So using the NAICS code 4451, that is a federal government specified code based on the industry that a business is in. And so 4451 was our grocery stores. And so what this is just a long list of a bunch of grocery stores with their addresses and information about their business dealings and their executives and their sales and all that kind of stuff. So if you're looking for business information, the library does have this source, which is pretty good. We can talk about it later. But this is where I pulled this. So we have multiple files that are all this same thing. They're set up the same way. They're just separate. So the first thing I'm going to do is I'm just going to take a look at all of the files that are available to me in my workspace. And so to do that, I'm going to use the OS list dir function, which essentially just goes through the current workspace and it lists all the files. All right, so in my files here, here's all the files that I uploaded. We can see this kind of hidden file called config, which is just part of the collab environment. And then we also have this folder called sample data. And then of course, there's probably more files in there. But for now, we're just interested in these files right here. We're going to use the partial string NAICS underscore 4451 to identify the files that we want to use from our list of files. So what we're going to do is we're going to create a blank list. Here's those square brackets again, using them in even yet another way, which is creating an empty list called flist. Then what we're going to do is we're going to loop through the files in our workspace. And if this data file name 3, which if we double check our variables here, data file name 3 is right here, and it has the value of NAICS 4451. If that string appears in the file name, then we're going to use the append method on the list to append that file to our empty list. So our list, flist, is going to start off empty, but then at the end, after we do this loop, it should have some records in there that we isolated based on this prefix, NAICS 4451. So let's run this. So these two lines here are a really powerful combination in Python. You've got your for list, which is going to loop through different elements, and then you have your if statement, which in this case is evaluating whether or not that prefix appears in my string. So now if I just print out flist here, I can see I have a list of these files. Okay, so that's good. So I'm going to hold that list now. Now what I'm going to do is I'm going to loop through that list. And the first thing I'm going to do is I'm going to create a data frame that is only the information from that single file. And then I am going to print out for that data frame, I'm going to print out the name of the file and I'm going to print out the shape. So that's all I'm going to do. I'm just printing out those things for now because I want to get an idea of how many records I'm talking about in these files and so on and so forth. So I'm just going to run that. And so this is telling me, okay, most of the files have 100 rows and 228 columns. We do have one file here that has 200 rows and 228 columns, but this is just a quick way to look at this at a glance because if there was like maybe different numbers of columns, then maybe that would indicate that we have different columns and then the join would be a little bit more complex. But in this case, it looks like all of those files are formatted the same. And so we can just go ahead and merge them all together. Okay. So next up, we'll do the merge. So this is kind of an offshoot of our read CSV function. But what we're going to do is we're going to combine this with some other functions here. We're going to nest them together. So the first thing we're doing here is we're creating a data frame called data combined. And then what is going to be in that data frame? Well, the first thing we're going to do is we want to read in the CSV files. And we want to read in each one of those CS files that is in flist, our file list here. Okay, so this map function here is basically saying, take this function and apply it to everything in the list. So the first parameter is what do I want you to do? I want you to read the CSV. The second parameter is what do I want you to do it on? I want you to do it on all of the items in this list. So it's going to go through and do that. But then what it's going to do is it's going to use the concat function or concatenate, and it's going to concatenate all of those data frames together. All right, so we're kind of nesting in a couple of different things happening here. First, we're reading through all the files in the list, and then we're going to concatenate them all together so that they end up in just one giant data frame. So let's run that and let's see what happens here. So we ran that without errors. That's good. Let's take a look at the shape of that. Remember that that shows the number of rows and columns. So now we have 600 rows and 228 columns. That looks pretty good to me. We can double check just by looking at the head. And yeah, we've got just this kind of giant, really wide data frame here with all of that information. I'm going to clear that output. Also, something that we can do, since there's 228 columns, that's kind of a lot. We might want to look at a list of those. So this is just running the .columns property to see all of the columns. Now, since there are so many of them, it kind of gives us the first several and then the last several here with this ellipsis here. If we wanted to actually look at all the columns, we could run a list, kind of similar to what we did with all the values of income at the beginning of the workshop. We can say, okay, for all of the columns in the data combined, go ahead and loop through them and print each one out. So we can see that it's like a pretty massive list here. There's lots of different executives that they give you names for and stuff like that. Okay. Okay, so we have this giant data frame. Let's see how far we can get in actually manipulating some of the stuff in this data frame. So if you are familiar with zip codes at all, and also if you have maybe ever lived on the East Coast, you know that a lot of zip codes in the East Coast start with 0, which can create a problem, especially if you're doing things with zip codes and maybe in Excel. You know, Excel is not a super big fan of leading zeros. It kind of likes to chop those off sometimes. And so you'll get a bunch of zip codes, some of which are only 4 digits. And then, of course, that is not a valid zip code. So, you know, places like New Jersey have a lot of zeros in their zip codes and so on and so forth. So we need to make sure that if a leading 0 does exist in a zip code, we need to account for that. In our previous data set, all of those zip codes were in Missouri. Missouri zip codes start with 6. So we didn't really have to deal with this in our previous table. But now that we're talking about locations across the United States, we need to make sure that we're accounting for these leading zeros for our zip codes. So let's take a look here. The physical zip is the name of the zip code column. So if we just run that, it gives us kind of a truncated list again. And so all of these are showing as 5 digits, which is fine. We can also take a look at all of the unique values of zip code. So if we click on that, we get a much bigger array. And now we can see, yeah, here's one with only 4 digits, here's one with only 4 digits, and so on and so forth. So we have to account for those somehow. All right. Well, the first thing that we're going to do is we're going to say, hey, Python, this zip code column is not a numeric column. It is actually a text column. So let's create a new column called physical zip string, or STR. And to do that, let's take the existing physical zip code, so that's these values here, and let's convert them to a string. So let's do that. Okay. And if we take a look at the unique values of this new column again, now we can see that all of the values are in quotes, which tells us that they're strings, but we likely still have our 4 digits there, 4 characters now. Okay, so we're going to need to do a little bit of padding here. So the first thing we're going to do is we're just going to figure out, okay, how many different combinations of characters do I have? And probably I'm going to have 4-character zip codes and 5-character zip codes. So to do that, what I'm going to do is I'm going to take the values in our new column, and I'm going to say, okay, pretend like this is a string and give me the length of that string. Oops, backspace. There we go. And then give me the minimum value of that and give me the maximum value of that, and then print those out. So the first item in this tuple is going to be the minimum string characters, and the maximum string characters will be the second one. Oh, and I was messing around with my thing, and so I think I did something wrong. Okay, there we go. Okay, so we've got 4 and we've got 5. Okay. So this is probably like one of the handiest string functions in Python in general, and that is zfill. All right. So what we're going to do is we're going to say, okay, we're going to create a new column called physical zip string 5. This means 5 characters. And to do that, what we're going to do is we're going to take the existing physical zip string. We're going to treat it as a string, and we're going to use the zfill method in Python. And what we're going to do is we're going to set this parameter to 5. So that means that if the incoming string has 5 characters, it's going to just take those 5 characters. If the incoming string has 4 characters, then it's going to fill in a leading 0 to make it 5 characters total. Okay. And then, so just as a double check, this code here is exactly the same as this code here, just getting the minimum and maximum values of the string lengths. We can see that now we're at 5 and 5. And also, if we call like unique values here, or if we loop through all the values, we're going to be seeing now, let's see, here's one right here. So here is a zip code value that it padded that leading 0 in there. So pretty handy if you're dealing with leading zeros with zip codes or anything else that you might have leading zeros for. Okay, so since we took a look at splitting values earlier when we were splitting our URL for the Google Drive, I'm going to bypass the splitting values section just for the moment, and feel free to work through this. This does another split, and this time it passes out the split values into other columns, because I want to just make sure that we do touch on dates really quick, because dates are also something that are a big pain to work with when you're doing data cleaning. So I just want to make sure that you're familiar with this particular built-in module for Python before we wrap up our workshop. So Python has a specific date time built-in module that is designed to work with dates and recognize dates and know that these dates are actually dates and times and not some other kind of numeric value. So in order to work with the date time module, we do need to import date time. We don't have to download anything again, but we do have to import it into our script. So in the tables of data, there is a date for the value that the year the company was established. And so you might want to do some analysis on like how long businesses have been in business. Okay. And so there's different ways you could do that, of course. Let's take a look at that year established column in our combined data frames. So it looks like it's coming in as a number. This D type is telling us float, which basically means this is a decimal and not an integer. And so, it's numeric here. If we wanted to, we could certainly, the year is 2025 now, we could just say 2025 minus this number, and that would give us the number of years in business, and that would probably be fine for some analysis. But if we want to really take advantage of the fact that Python can recognize these date times, we can actually do some more precise math here. So what we're going to do is we are going to take this year established column. We're going to create a new column called established underscore date. So to do that, what we're going to do is we are going to call this to date time function. So previously we used the Python to numeric function, or excuse me, the pandas to numeric function. Now we're using the pandas to date time function. And so what we're going to do is we're going to pass through that year established value, and we're going to tell Python, okay, what is the format of this date coming in? And we can see that this is just a 4-digit year here. So this little artifact here, this %y, indicates a 4-digit year. And if you look at this link here, there's more information on what is valid for that format parameter. So if we run this and we take a look at our established date, now we're seeing a column where these dates look much more like dates, not just like numeric years. So then what we can do is we can create a new column called current date, which essentially uses this pandas function that just takes the exact date for today and inserts it in. So if we run that, we're going to have a new column now in our data frame called current date, which we can see is today. All right. So here's where the magic of the datetime module comes into play. We will use the time delta function that's part of NumPy. And so we're going to create a new column called years in business. And what we're going to insert into that column is this expression here. So we're going to take today's date, we're going to subtract the established date, and then that's basically going to give us the date, I want to say in something crazy like, I don't know, milliseconds or something like that. And then if we divide it with by the year divided by 1 year, then that's going to give us the number of years. So this NP time delta year is what's going to actually do that conversion into years. So now if we look at the data combined years in business column, and looks like we've got another error. So what is this telling us? It's telling us that the unit Y is not supported. Only these values are supported. Okay. So, this might be a good time to say, look at this little AI generated explain error thing. Okay, cool. See, now maybe AI is going to be kind of useful to us here. So this is giving us kind of an explanation of what we think might be happening there. And then it gives us kind of a suggested way that we can update this. So what this is saying is go ahead and just divide this by full on 365 to get your number of days. And so we've updated that here. And so when we look at our years in business now, we can see we've got some solid numeric values to do whatever analysis we're going to do on these years in business. Okay. All right, so we made it a little bit into the dates, which I'm happy about because I did want to make sure that we touched on date times just a little bit, but feel free to continue to look at some of the other date items that are in this particular workbook. With that, I'm going to just say thank you to my friends here in the room who came to Instruction Room 2 here in Olin Library. And thank you very much to you on Zoom for hanging with me for these 2 hours learning about Python. I'm going to go ahead and stick around in case anybody has any questions, but this is going to conclude the content portion. So as you work through this, feel free to reach out to me if you have any questions, and happy coding. Thank you so much.